All right, you guys, I'm just gonna work through our Unit 5 review to help answer any questions you may have or just help you check your process and use as an answer key. So here we go. It's kind of broken up by topic. So we have 4 major topics, right? We learn our 3 methods and then our word problems. So here we go. Number 1, write the equation of the system and then list the solution. Okay. I'm just going to use this increasing line right here as equation number 1, and then I will do this line as equation number 2. All right, so for equation number 1, I want to find his slope. All right, so it looks like he's going up 2 over 1, up 2 over 1 with a y-intercept of negative 2. Right, here's his y-intercept right here. So that means his equation in y equals mx plus b, so the m is 2, right? That's your slope. And then our y-intercept is negative 2. So 2x minus 2. Sorry about that. All right, and then the other line, let's see, it looks like he's going through this point and this point and this point, right? And so that looks like he has a slope of up 2 over 3. Okay, so his slope, so up 2 over 3, so 2/3 x, and then his y-intercept is at positive 2, so we're gonna write plus 2. All right, and then the solution is, of course, the point that they have in common, right, which is going to be 3, 4. Or x equals 3, y equals 4 if you want to write it out, but you can just write the solution as that ordered pair. If you have a question like this on your test, I would definitely use Desmos to your advantage and to check your answer. And I would type in my y equals mx plus b's and see if I have these exact same 2 lines that intersect at the point 3, 4. Because if I happen to mess up any of my signs or my y-intercepts or my slopes or anything like that, then that'll help me figure that out by using Desmos to check my answer. Okay, so you want to take advantage. All right, number 2, instead of giving you the actual graph of the lines, they're giving you a XY table for each line. So we're going to basically do the same thing. So we're going to find the slope, we're going to find the y-intercept, right? Luckily for us, the tables that we give you guys are pretty friendly. So for example, oops, sorry, I meant to highlight. I know that 0, 3 is the y-intercept, right? Which is very nice. I don't have to go figure that out, right? And I happen to notice over here, they also give me the y-intercept, and it's also 3. Well, that's quite the coincidence, because not only do they did the tables give us the y-intercept, but it's the exact same y-intercept, which means not only is it the y-intercept, but it's also the solution, because that is the one point they have in common. So if I were to graph these 2 lines, right, they're both intersecting at 0, 3. Okay, and remember, you can also use Desmos and type your tables in. Oops, sorry about that. To do that. You can type this entire table into Desmos and go run that linear regression, and it'll graph the line for you and give you the equation, right? So we talked about how we can use Desmos to our advantage if you feel like you need it. I still need to find the slope though, right? Remember, slope is change in y's. Well, it looks like my y's are going up by 1, and it looks like my x's are increasing by 3, which means my slope, remember, is change in y over change in x. So 1/3 would be my slope. So y equals 1/3 x, and then of course the y-intercept of 3. Then I go to my other equation, right? It looks like my y's are actually going down by 1, and my x's are going up by 2. So that means that his slope, change in y's, -1, over change in x's, +2. So his slope is -1/2. So y equals -1/2 x, and then of course the +3, because that's the y-intercept that the table gave us. Again, if you are not 100% sure about your thought process with that table, use Desmos, right? Go put the table in Desmos, go hit that little regression button, right? It's the one that looks like this, you know, on the side of your screen in Desmos. Go tap that button and it's going to tell you what the equations of the lines are, and it will show you the intersection point. So you can literally get all of this information for free in Desmos by just plugging those tables in and knowing how to use it. If you don't know how to use Desmos or you forgot, please ask, okay? All right, number 3, writing the inequalities of the graph and then listing a solution. Well, of course, remember, the solutions are all the points that exist in this overlapping shaded region, okay? Because we have this line that we've clearly shaded above, right? And we have this line, which we've obviously shaded below, right? And so that dark gray region is our solution overlapping, where they share the same solutions. Okay. All right. So now we need to write those. Unfortunately, Desmos is not going to do this one for you, right? So you're going to have to do this one yourself. It's very similar to number 1, except you have to make sure that you're using an inequality, right? So as soon as you see shaded regions, you know you're either going to use less thans, greater thans, less than or equal tos, greater than or equal tos, right? You need to be using one of those 4 symbols when you write your y equals mx plus b equation. Okay, I'm going to go ahead and I'm going to make this one my first line. So the first thing I'm going to do is go find my slope. Like, let's go get the mx plus b. All right, so it's y. I'm not going to put an equal sign because this is not an equation, it's an inequality. I'm going to save that for last though. Let's see, it looks like our slope is -1. So I'm just going to put negative x. And then it looks like our y-intercept is 0. So if you want to write negative 1x plus 0, then that is totally fine. Okay. Or if you just want to write negative x, then that is fine as well. So that is the equation of the line, but this isn't just a line, it's an inequality. So the first thing I notice is that it's a solid line. And if it's a solid line, then that narrows it down to one of those 2 options because it has to have the equal to bar. And then the next thing I need to analyze is, where did they shade? Well, for this line, clearly all the shading is above the line. And if all my shading is above the line, then that means I need the greater than symbol, right? Which means I've narrowed it down to this one. Right, so it has to be greater than or equal to, and there's our inequality. Okay, all right, I'm gonna do the next line. Let me change colors here. So I'm gonna do this guy as my second inequality. All right, so let's go find the slope. Let's see, it looks like it's going through this point. I don't hit another point, I don't think, until here. Yeah, yeah. So let's see, that's going up, was that 5? 1, 2, 3, 4, 5. Yes, I'm going up 5 and over 4. Okay, so it looks like our slope is 5/4. So 5/4 x. And then my y-intercept for that line is +1. Okay, so now I need to figure out, oops, I didn't mean to erase that dot, there we go. Now I need to figure out which inequality symbol it's gonna be. It's gotta be one of these 4. So let's see, it's a dashed line, right? Which means it takes out those 2. It's gotta be one without an equal to bar. And then I need to figure out if they shaded above or below the line. Well, clearly all of my shading is down here, which is below the line, less than, right? I'm using all the y's that are less than my line. Okay, so that narrows me down to the less than symbol, and that's the one that I have to use. Right, and there you have it. All right, and now that we've established that, now we just need to find a solution. Well, remember, there's infinite solutions, and they all exist in this overlapping space. So you just need to pick any point that exists in the overlapping shaded region. I'm gonna pick 3, 2. I'm just going to pick this point right here, right? Any point will do. You don't have to pick the same point as me. Just pick something that's in the overlapping shaded region. All right, let's get to number 4. Number 4 says solve by graphing. It's already in y equals mx plus b form, which is super nice. So basically, I'm just going to graph each one of these lines. So I'm going to make this my first one. Okay, so let's see, y equals negative 2x plus 4. So we start at 4. And then our slope is negative 2 over 1. So down to right 1, down to right 1, down to right 1. I'm going to keep that going so I get a nice pretty straight line. Notice it's a decreasing line, which it should be because my slope is negative. All right, then I'm going to graph my second line, which is just y equals 2x. Remember, there's an understood little plus 0 hanging off the end there because our y-intercept is 0. And then our slope is positive 2 over 1. So that means we're going to go up 2 over 1. Oh, voila. Looks like we already found our solution, but I'm still going to graph my nice straight line here. All right, so slope of positive 2. So there's my 2 equations. And then, of course, our solution is the 1 point they have in common, which looks like that's going to be 1, 2. Okay. Now, if you have time on your test, you should totally check your answer, right? And you can check this in Desmos. That would be a wonderful way to check it. You can check it algebraically, right? By simply just taking the 1 in for the x and the 2 in for the y. So if I do 2 equals negative 2x, which is 1, plus 4, right? If I do that math, I get 2 equals 2. Yay. And then I plug it into the other equation and see if it works. 2 equals 2 times 1. Well, notice that also gives me 2 equals 2. Yay. All right, so I do a little happy dance, and I'm like, yeah, 1, 2 is the only point that works for both of those equations at the same time. Okay, that took me less than 10 seconds. Okay. All right. Number 5, more solving by graphing, but these are in standard form. We've talked, now that we learned all the other forms, right? Obviously, if somebody asked me to solve this, I'd probably use elimination method because they're in standard form, but we're asking you to specifically show us how to solve it by graphing, right? So we are going to have to put in that little extra effort of converting them both into y equals mx plus b form. All right, so here we go. We've done this a million times, right? If I want to get something in y equals mx plus b form, I need to move the x term over. So I'm going to bring down the negative 2y, and when I move the x over by subtraction, he's going to become negative on the other side. And then, of course, everybody needs to get divided by that negative 2 multiplier so we can get the y by itself. All right, so let's see. That is going to give me y equals, now remember there's an understood 1 right there, so that's going to give me 1/2. And then a positive divided by, a negative divided by negative is a positive. So positive 1/2 x is what we're going to get there. And then negative 9 divided by negative 2. I know that doesn't divide evenly, but it is a nice little 4.5, right? So it's not terrible. So I'm going to graph that line. So just be really careful with the 4.5. So 1, 2, 3, 4.5. So I'm going to go up to 4.5. Now, when I do a slope of 1/2, I'm going to go up 1. Now I'm at a half, which means when I go up 1, I'm going to be at another half over 2. Now I'm off my graph, so I'm going to go backwards. So I'm going to go down 1 full unit and then over 2, right? And that's going to land me right here, right? And then I can go down another full unit over 2, and that's going to put me right here, down a unit over, sorry about that, 2. You get the gist. So there's our line right here. Okay. Now we need to go do the other line. All right, so let's see. We need to take our x term to the other side, same steps, right, that we always do. He's a negative 3x though, so we have to, so we have to add him to the other side. So I'm going to bring down my negative y. Don't forget the negative on the y. When I add the 3x to the other side, he's going to become positive. And then I need to divide everybody by -1 to get that y by itself. So y is going to equal -3x plus 1. All right, let's see how this turns out. We're going to start at 1, and then our slope is -3, so down 3 over 1, down 3 over 1. But I'm going to go backwards, up 3 over, oh, looky there. Ta-da. Right, it does hit our other line at a nice, pretty point. Thank goodness. Okay. And so our solution is going to be this exact point that they have in common, which it looks like that is -1, 4. Again, you can use Desmos to check your answer. However, you are banking on the fact that you have put them in y equals mx plus b form correctly, right? If you made a mistake going from standard to y equals mx plus b, then Desmos isn't going to help you, right? But what I can do is I can check my answer using my original equations. Right? Don't use the equations that you've done work on because maybe you've done wrong work, right? So go check it with the originals. Okay, so I'm just going to do this really quick. Hold on, I'm going to scooch this up here. All right, so let's see. Our first equation was x, okay, -1 minus 2y, but I'm getting 4 for y. Does that equal -9? Well, let's see. -1 minus 8. Yeah, that does give me -9. Yay. Then I got to go check the other one, though, because it has to work for both. So -3 times -1 minus 4, does that equal -1? Well, this gives me 3 minus 4. Oh, what do you know? That is -1. Yay, right? So that guarantees, right, that my answer is correct, right? And I did all of that algebra by putting them in y equals mx plus b form correctly. Okay, again, that doesn't take very long. It's totally worth the time. All right, number 6 is graphing more, but it's graphing inequalities, right? So you need to catch that those are not equations, they're inequalities. So let's see, we need to do a little work on this first guy. Do you notice he's not in y equals mx plus b form quite yet? It looks like we need to get the constant over there. That's weird, but that's okay. So we're going to move the +1 to the other side, which is going to give us 2x minus 1. All right. So no big deal. Just move the constant over. And I do want to pay attention before I actually graph this line, what the greater than symbol right there is telling me, right? So remember, the greater than tells me that it's a dashed line because it does not have the equal to bar. And it also tells me, because it's greater than, that we're going to shade everything above the line because that's where all the greater y values are. All right, so I'm going to keep that in mind when I graph my line here. So let's see, we're going to start at -1 with a slope of 2. Okay, so I'm going to go up 2 over 1. Let me finish the rest of that off. And then before I just draw the line, I want to remind myself, oh yeah, but it's dashed. So I want a dashed line. And I want to shade everything above. I want to get all the greater y values, which lie above the line, right? So I'm going to shade this side. So it should look like this. All right, then I'm going to graph the other inequality. He's already set, right? He's ready to go. He's already in y equals mx plus b, but I do want to take a quick note to see that that is a less than symbol, which means he's also going to be dashed because he does not have the equal to bar underneath, but less than means we're going to shade below the line where all the lesser y values are. Okay, so I'm going to go graph 1, 2, 3, 4, 5. There's my y-intercept. And a slope of negative 1/3 means down 1 over 3. I can't really fit a whole lot. So that line is way up here. Oh, silly me. Dashed. I forgot my own little thing that I just wrote down. It's a dashed line. I almost forgot. And we're shading below, right? So everything below this line contains the solutions to that inequality, which is pretty much the entire graph, right? But as far as our solutions go, our solutions for the system are the overlapping space, right? And you want to make sure that on your test, I know exactly which space you want me to look at, right? So you might want to shade it in darker or use a highlighter or something like that, because this is the solution region for our system. So all those infinite points that exist in there are solutions to this system of inequalities. So when it says possible solution, okay, just go grab one. I'm just going to randomly pluck one out of here. I'll just pick this guy right here for no reason, just because he's in that region. What is that, -3, 1? Sure. Right? Any point in that yellow region will do. All right, let's go do one more of those. Here we go. So on number 7, notice this guy is in standard form. That's no good, right? So we're going to have to put him in y equals mx plus b form. Whoa. So that means we need to move our x term to the other side. Put him right here. So that's going to give me positive 2y is greater than or equal to negative 4x. Please don't forget you're subtracting that 4x to the other side. He has to change sign. Minus 6. Now I still need to get the y by itself. In this case, I'm just dividing by positive 2, which isn't going to change anything. But please remember, right, to ask yourself, do I need to flip the symbol, right? There's not an example. I wish there was. There's not an example on your review where you have to flip the symbol, right? But we've done that plenty of times, so make sure you remember that. I'm going to put a little reminder. Flip the symbol when dividing by a negative. Sorry, that's really sloppy. Right now, in this case, we're dividing by a positive 2, so we don't need to flip the symbol, right? So just keep that in mind, though. So this one's going to stay a greater than. Let's see, that gives me a slope of -2 and then a y-intercept of -3. All right, so that's going to be our equation. I also noticed that this is a greater than or equal to, right, which tells me 2 things. It's going to be a solid line because it has the equal to bar, and we're going to shade above because it's a greater than. I want where all the y values are greater than the line. All right, so let's go graph that. Let's see, a y-intercept of -3 and a slope of -2, which means down 2, right 1, or up 2, left 1, to get these points all over here. And it's a solid line. So I want to make sure, remember that. That's a little crooked, but that's okay. And y is greater than, so I want the side that contains all of these upper y values on that y-axis. So I have to shade this side. All right, now we need to go graph our other line. Now remember, this is x is less than or equal to -3. So notice this is just an x equals -3. So you need to remember what that means, right? X equals equations are vertical lines, right? X equals equations are vertical lines, right? So we want to remember that from last unit. I do have a less than or equal to, so that means we are going to have a solid line. Now this one's kind of confusing because I'm not talking about y values anymore because there is no y in this equation. So now I'm talking about x's, and x's are not up and down, x's are left and right. So if it's x is less than, then that means I'm going to shade left, right? And I only do left right when it's just x only, right? So when I do x equals -3, that's this line, kind of. See if I can actually get on the line. There we go. So solid line at x equals -3, and then I want all the x values that are less than -3, which means we're going to shade to the left, right? So all of my solutions to this inequality lie here. Well, that's not a whole lot of overlapping space, right? Because the only overlapping space we have between these two guys is this little spot here. Now, of course, it does get bigger as the graph gets bigger, right? Because it's infinite solution and our planes go on forever and ever and ever, right? But on our little graph, it is a pretty tiny solution region. All right, and then we just need to pick a point somewhere in there. Now, because these are solid lines, I can also pick a point that's on one of the lines because they're solid. And I'm going to do that because unless you want to pick a fractional value that's in there, or if you want to go to something that's off our graph point-wise, which would be totally fine as well. So let's see, 1, 2, 3, 4, what is that, -4, 5. Again, if you want to pick something off the graph like -4, 10, right, that would be totally fine as well. That would be in the shaded region if we were to expand the graph. All right, number 8. This is where we started solving by substitution. All right, so I'm going to go through these pretty quickly. Remember, when you solve by substitution, you need one of your equations to say x equals or y equals. Right? One of them needs to say that. If it doesn't, then you need to doctor up one of your equations to make that happen. So I happen to notice on this one, none of my equations say x equals or y equals, but one of them is oh so close. Do you notice this y right here? Hanging out by himself without a coefficient in the front. He is almost by himself, as long as if I were to take this 2x and move it to the other side, kind of like we're putting it in y equals mx plus b. It's not really my intention, but so we're going to get y equals -2x minus 11. And that is what I need to use the substitution method. So now that I know that y equals -2x minus 11, that means wherever I see another y, here's one. Right, we're going to substitute that expression in for the y value in the other equation. All right, I know this is just like our notes. I'm going to have arrows all over the place just so I don't lose anybody. So I'm going to take that top equation and I'm going to completely rewrite it. So here we go. So -2x minus 7, but I'm not going to write times y. I'm going to write times, and I'm going to substitute in -2x minus 11, since I know those two things are equal to one another. And then don't forget to finish it off and bring down your equals -13. So all I've done is I've rewritten that top equation. I've just substituted that -2x minus 11 in for y. And the reason we do that is because now I have an equation with only x's. And that is an equation that I can solve. So we're going to do the same 3 steps that we always do, right? You have to distribute to get rid of parentheses. All right, I'm going to bring down my little -2x hanging out in the front. -7 times -2 is positive 14x. And -7 times -11 is -77. All right, so we've distributed. Now we need to combine like terms, which we definitely have. X is on the same side. So -2x's and 14x's gives us 12x's. right? And now we need to solve our basic two-step algebra equation, right? So we need to move the negative 77 to the other side by adding. So that's going to give us 12x equals 64. And then we're going to, well, that doesn't give us a very friendly number, does it? Sorry. And then we're going to divide by 12. And that's going to give me not a friendly number. It's going to give me 5.3 repeating, right? Or 5 1/3. But I'm just going to go ahead and write that as 16/3, right? Remember, use math, enter on your calculator to figure that out. Now, I'm going to go double check my math really quick. And you know what? I happen to notice that I made a mistake along the way. Most of the answers we give you guys are going to be whole numbers. They don't have to be whole numbers, of course, right? But if I got this weird 16/3, I'm going to go back and just take a quick double check of what I did up here. And you notice what jumps out at me right away? And some of you guys were probably yelling at me as I was talking about this, right? Right here, when I distributed the -7 times the -11, I just noticed that I wrote -77, but a negative times a negative is a positive. So that means all of this is wrong right here. So I'm going to just go back. No biggie, just erase it. We all make mistakes. I'm going to change that to a positive 77. And let's see if that makes our answer nicer. So I still have 12 x's when I combine. Plus 77. All right, now I'm going to actually move the positive 77 to the other side by subtraction. Okay, let's see, that's going to give me, oops, I'm going to change color, sorry. All right, so now I'm going to get 12x equals, what's that going to give us? -90, right? And so if I divide 90 by 12, divide by 12, let's see, that's going to give me -7.5. So not a whole number, but a nice finite decimal, right? 0.5, that's not bad. All right, so that looks a little better to me. But I'm going to check my answer at the end, so it's all good. So I'm going to go with that. Assume I didn't make any other silly mistakes. And now I need to go find y. Okay, so I'm going to go up here, and I'm going to go back to my y equals. Or you can go back to one of your original, you know what? I'm going to practice what I preach here. I'm going to go back to one of my original equations. Because if I mess that up, then I don't want to use something that I did wrong. So here we go. So 2x, which was -7.5, plus y equals -11. All right, well, 2 times -7.5, that's -15. And so then the only thing I would need to do to solve for y is just add the 15 to the other side. And that gives me y equals 4. All right, so I'm banking on the fact that my answer is -7.5, 4. But you know what I'm going to do? You know what? I'm going to check that answer. I'm going to go green. Now, I don't really need to check both equations necessarily because I literally just used that bottom equation to get that answer in the first place. So I'm just going to go use the top equation, the -2x minus 7y equals -13. And I'm just going to check to see if that works. So I'm going to plug in my -7.5 minus 7 times y. And I'm going to ask myself, does that equal -13? Well, let's see. This is, let me write it down. This would give me 15, and this would give me -28. Is 15 minus 28 -13? It is. Oof, thank goodness. Right, and so that's when I do my little happy dance. And I realize that my answer is -7.5 for x. Okay, now that means I'm going to write my answer as -7.5, 4. and I want to write my answer as an ordered pair. Woof, that took a long time, having to overcome my mistake there, right? But I figured something was wrong. I went back, I found my error, then I checked my answer at the very end just to make sure that it was correct, right? I know that took a lot of time, but on a test, if I'm looking at a 10-point question, I don't want to miss 10 points, right? Just because I was too lazy to go back and find my mistake or to check my answer, okay? All right, here we go. Solve by substitution on number 9. Well, this one looks oh so fun. Okay. We didn't really have any where we had to do fractions, but that's all right. I'm totally going to solve for this x because he's almost by himself anyway. I just need to move this positive 1/2 y to the other side. So that's going to give me x equals negative 1/2 y plus 10, or 10 minus 1/2 y. It doesn't really matter where you put it. All right, so now that I know that x equals negative 1/2 y plus 10, then wherever I see the x in the other equation, there it is, I'm going to substitute that in. Now, I know that looks kind of gross with the fraction, but don't worry, and you have a calculator, so it's not that big of a deal. And it's a friendly fraction, it's a half. So 6 times, let's see, I'm not going to write x, I'm going to write negative 1/2 y plus 10. And then I'm going to bring down all the other stuff. There we go. All right, same old, right? We're going to distribute. What's that going to give us? 6 times negative 1/2 is negative 3y, and 6 times 10 is 60. And then minus 5y equals 12. Okay, then I have like terms, right? I've got a negative 3y and a negative 5y on the same side of the equal sign, so I can combine them, which gives me negative 8y. And now I have a basic 2-step algebra equation, so we're just going to solve it as usual, right? We're going to subtract the 60. What's that going to give us? Negative 48. And then when we divide by negative 8, right, we end up getting y equals 6. That's a nice, pretty number. Pretty confident in that. All right, and now that we have our y, we're going to go find our x. Let's see. If you want to go back, you totally can use any equation you want. If you're confident in your work, I'm just going to be confident in my work here, and I'm going to go plug it back into my x equals equation. But you can plug it into this one or this one. It doesn't matter. You're going to get the same answer for x. So I'm just going to use this guy, though. So x equals negative 1/2 of 6 plus 10. Well, negative half of 6 is negative 3, and negative 3 plus 10 gives me 7. So it looks like our solution is 7, 6. Voila. I'll highlight that. Now, you better believe I'm going to go check that answer. Get back up. So I'm going to go over here. I'm going to check my answer. Now, I already used basically the top equation to find x, so I'm just going to check it with the bottom because I don't think I need to do both since I used the other equation anyway already. So I'm going to do 6 times 7, I'm using the bottom equation, minus 5 times my y, and I want to know, does that equal 12 like the equation says it should? Well, let's see, 6 times 7 is 42, 5 times 6 is 30, is 42 minus 30 12? Yay, it so is, right? So I'm feeling super confident about all my algebra work there. All right, moving on. Elimination method, all right? So this is where we need our one of our variables to eliminate each other, right? We needed everything in standard form. Notice the x's, the y's, the equal signs, and the constants. They're all vertically aligned, which is exactly what we want. Now remember, the elimination method means we're adding vertically, but we can only do that if one of our variables cancels, and that is not happening yet, right? A negative 2 and a negative 7x, those don't cancel. A positive 6 and a positive 8, those don't cancel. And this is one of the hardest problems. I don't know, I wish we would have started with something easier, but that's okay. You need to pick a variable to cancel. It does not matter which variable you pick. I'm just going to pick the x's just for no reason. So I need to ask myself, obviously 7 is not a multiple of 2, which means I'm going to have to change both of these equations. So I need to think of the smallest multiple that 2 and 7 have in common. Well, that's going to be a 14. So I need to turn one of these x terms into a positive 14x, and I need to turn another one into a negative 14x. It doesn't matter which one. So I'm going to multiply the top equation by 7. So notice when I do that, that's going to give me negative 14x plus 42y equals 42. Don't forget to take the 7 all the way across to everybody. So I've got a negative 14x out of that, which means I need this guy to turn into a positive 14x. And the only way I can get a negative 7 to turn into a positive 14 is by multiplying by negative 2. So that's going to give me positive 14x minus 16y equals positive 10. Make this a little bigger. And now I can add vertically because now my x terms cancel. Okay, and that's the whole goal. So now I can add everybody else. 42 plus negative 16 is going to give me 26y's, and 42 plus 10 gives me 52. And then I just have this easy peasy little algebra equation to solve, where I can just divide by 26 to solve for y, and that is a nice pretty y equals 2. All right, I still need to find x though, so I am going to go back up to one of my original equations. It does not matter which one you pick. I know I'm like a broken record. I say that a million times a day. All right, so I'm just gonna go back up to my top original equation. You could use any of these two, but you run the risk of not being able to read your handwriting or making a silly mistake there. So I'm just gonna use the negative 2x plus 6y equals 6. So here we go, negative 2x plus 6 times y, which I just found out was 2, equals 6. And then I'm going to solve this algebra equation. Obviously, that gives me 12. So we're going to subtract 12 to the other side. So we're going to get negative 2x equals negative 6. And when we divide by that negative 2, we end up getting x equals 3. So our final answer would be 3, 2, right? Making sure we put that in X, Y order. All right. Now, of course, if I were you, I know you're so sick of me doing this, but I'm going to check my answer. Now again, I already used my top equation to find x, so I should be good to go there. So I'm just going to make doubly sure if I use the bottom equation and plug a 3 in for x and a 2 in for y, do I get negative 5 like that second equation tells me I'm supposed to? Well, let's see. That gives me negative 21 plus 16, and what do you know? That does give me negative 5. Right, so he works in both equations. Yay. All right, almost done. Number 11, solve by elimination again, right? So again, everybody's lined up, so we're ready to go. We're all in standard form here. But again, none of my variables cancel. Now in this case, I'm going to choose to eliminate my y's just because 2 is a multiple of 1. And so I can just get away with manipulating one equation instead of both. If you want to cancel out the x's, that's cool too, but you're going to have to turn them into 10s because that's the least common multiple that 2 and 5 have in common. So it doesn't matter which variable you pick. But I am going to do the y's, and I notice this guy is already a negative 2, which means I need to turn this one into a positive 2. And the only way I can turn a negative 1y into a positive 2y is by multiplying by negative 2. So that's going to give us 4x plus 2y, which is exactly what I wanted to happen, equals 18. Now I'm going to bring down and rewrite my other equation underneath it. I like to keep my equations always aligned vertically so I don't ever lose track of where I'm at in my math problem. Right, so here's my system after I've manipulated the equations. So now I can add vertically. So my y's cancel, and we are left with, let's just go with gray. No, I'll go with green. Sorry, so 9x equals 36. Make sure you add your constants. And when I divide by 9, we get x equals 4. And then I just need to pick an equation to plug that back into. It doesn't matter which one. I'm going to use the bottom one since I haven't really messed with that a whole lot. So here we go, 5x, but I just found out x was 4, minus 2y equals 18. So that gives me 20 minus 2y equals 18. So I need to subtract that 20 to the other side, which is going to give me negative 2. And then I need to get rid of the negative 2 multiplier on my y. So I should be getting positive 1. So my answer should be 4, 1. Now again, I have a few spare minutes, so I'm going to go over here really quick and just check my answer. Now I already used the bottom equation, so I'm going to go ahead and just double check it with that original top equation, that negative 2x minus y equals negative 9, and just make sure my answer works there too. So negative 2 times my 4 minus the y, which is 1, right? Does that give me negative 9? Well, that gives me negative 8 minus 1, what do you know, which is negative 9. Yay. Okay. All right. Talking about the application problems. Okay. So here we go. Notice all the steps, right? We talked about this before on your quizzes and stuff. It's asking you to do 3 things. Identify your variables. So what do x and y equals in your equations? Set up your system, right? And then solve it. And you can use whatever method you'd like to solve it. But you should pick the one that's most appropriate, okay? All right, so here we go. Bill and Mike bought a CD player for $150. Bill paid $20 more than Mike. How much did each person pay? Okay, so before you even get started, you need to identify what you want your x and y to equal. And remember, the place we go find that is the last sentence. How much did each guy pay? That's what we're looking for. So that's our variable. So how much did each guy pay? All right, I'm just going to have x be Bill. You can make x Mike if you want. It doesn't matter. So how much did each guy pay? So amount Bill paid, and then amount Mike paid. That's what we're looking for, right? Money, right? So our variables are representing money. Okay, so now we go look at our sentences. The first one says they bought a CD player together, right, for $150. Okay, well then that must mean the amount Bill paid plus the amount Mike paid has to add up to $150, right? Together they paid $150. Then our second sentence says Bill paid $20 more than Mike. This is a write it as you read it, right? Go find your verb. Remember, your verb is your equal sign. So Bill, okay, well, Bill was X. Paid, so that's my equal sign, or Bill is 20 more than Mike, right? If you want to use the word is instead of paid. 20 more than Mike. Okay, well, so Mike plus 20. So y plus 20, or 20 plus y, right? It's addition, so the order that you write those does not matter. And there you go. There's your system of equations. Now you get to solve that however you would like. Now I personally am going to solve it by, let's make it a little smaller. I'm going to solve it by substitution because I have an x equals equation, and that means it's very much set up for me to do the substitution method, right? Because if x equals y plus 20, then wherever I see another x, I can substitute in a y plus 20. So that's what I'm going to do. So I'm going to make a little line over here. So I'm going to use, let me write this down. Now, does that mean you have to use the substitution method? No, it doesn't. If you want to put them in y equals mx plus b form and graph it, okay. That seems like a big waste of time to me, but that's okay. You'll still get the same answer. If you want to move the y over and then use the elimination method, that actually would be pretty cool, because if I move this y over, I have to subtract it, and then my y's would cancel. So I could totally see that being a viable way to solve this problem. It doesn't matter what method you pick. We would all get the same answer if we did our algebra correctly, okay? I'm just using substitution method because it's already kind of prompting me to do that the way that it's written. So here we go. I'm going to rewrite my green equation up there, but instead of x, I'm going to write y plus 20 plus y equals 150, right? So here's that y plus 20 that I substituted in. I didn't really need parentheses around it though, because it didn't have a coefficient multiplier in the front, but I am going to add my two y's together. And then I'm going to subtract the 20 and solve my little two-step algebra equation here. So 2y equals 130, and then I'm going to divide by 2. And let me cross that off. There we go. And it looks like I'm going to get 65. All right. And then I need to solve for x. Well, I can go back to either equation. It doesn't matter. I'm going to go back to my x equals equation. So if x equals y plus 20, right, that's going to give me 85. And of course, I can just check the reasonableness of my answer, right? Did one guy pay $20 more than the other? Yeah, $85 is 20 more than 65. If I add 65 and 85 together up, do I get $150? Yes, I do, right? I do want you to write your answers though in sentence form that's in context. So I'm going to say Bill paid, let's see, he was X, so that means he paid $85, right? And Mike, sorry, I didn't have a lot of room here. Mike paid $65, right? So I do want you to write your answers in context of the word problem. Oh, it's going to take that whole line with me, isn't it? Oh, it so is. Hold on. There we go. I think I can just do it. There we go. I'm going to put my answer down here. Kind of. Sorry, I know this probably drives y'all crazy. There we go. Just gonna make this look a little nicer. There we go. Now it fits. Okay, that's my OCD. Okay, voila. Okay, a few more to go. I hope these are all word problems. Okay. Anne and Jude decide to go bowling together. All right. Anne's score was 30 points better than June's. Together, they bowled a combined score of 410. Find each of their bowling scores. Okay. Well, I know I need to identify my variables. And I know that comes from the question or the statement in this case, right? They want me to find bowling scores. Okay, so I'm just going to say X is Anne's bowling score and June's score. Again, these are not dependent on each other, so X and Y, it doesn't matter which one you put where. Okay, so Anne's, now I'm going to go back to my little sentences here because each one of these little bullet points, right? It's just written in bullet points instead of a sentence. It's okay. Anne's score was 30 points better than June's. Okay, so that means Anne's score, X, is June's score plus 30 points better. right? Better just means more than, right? So we know we're adding 30 points onto June's score to get Anne's score. All right, then it says together they bowled a 410. Okay, well, together means to add, right? So x plus y equals 410. So that is our system. Scoot you that up here. Now I'm going to use substitution method again because it's set up that way. Again, if you want to use graphing or elimination method, then that's totally fine as well, right? You do not have to solve yours the same way I'm solving mine. So if x equals y plus 30, right, that means I'm going to substitute that expression in for that x. So let's see, that's going to give me, write it in purple. So that's going to give me y plus 30 plus y equals 410. All right, which gives me 2y plus 30 equals 410. Oops. I'm going to subtract my 30. So 2y equals 380. And then I'm going to divide that 2 off. And so I'm going to get y equals 190. That's a pretty good score. All right, and then I need to go find x. Okay, well, I'm just going to go back to my x equals y plus 30. So I know I'm just adding 30 to June's score, which would give us 210. I'm sorry, 220. And of course, I'm going to double check my answer, right? Is Anne's score 20 points or 30 points higher? Yes. If I add these two together, do I get 410? Yes, I do. Right, those are some very nice bowling scores. So I'm going to write my sentence as June or Anne Anne's score was 220 and June's score was 190. So just a nice brief sentence, right? Telling what the X and Y mean in context of our variables. All right, I'm gonna move on, try to get through these last few really quickly. All right, one wall inside a shoe store is used to display walking and running shoes. There are 140 pairs of shoes in this display. There are 2.5 times as many pairs of walking shoes as there are running shoes. How many pairs of walking shoes and running shoes are on display? Oof, that is wordy. Okay, so we're just gonna start. It's the same steps over and over again. So no matter how wordy it is, always start by identifying your variables, right? Which again, comes from your question, right? Variables are your unknowns, right? And the question tells us what we are trying to know, right? So how many pairs of walking shoes? All right, so I'm gonna just do number, pairs, walking shoes. And then I'll have Y be number, pairs of running shoes. Okay, so now that I've established what I'm looking for, right, number of pairs of shoes, I'm going to go to my sentences here. There are 140 pairs of shoes in the display. Well, that's the total. All right, so if I add all the pairs of walking shoes plus all the pairs of running shoes, I should get 140 pairs of shoes. Now, the next one's kind of tricky. We talked about this in class the other day. There are 2.5 times as many pairs of walking shoes as there are running shoes. Okay, so there's more walking shoes. So how are we going to figure out the walking shoes? Well, the walking shoes, X, is 2.5 times more. So 2.5 times the number of running shoes. So x equals 2.5y is the equation that we're going to get for that one. All right, and there's our system. Oops, sorry about that. I'm going to scooch that kind of over here. All right, I don't know why all of these are substitution method, but I'm totally going to use substitution method yet again, right? Since we got x equals 2.5y. So I'm going to use that and plug that back into that top equation up there. Make a little line to kind of separate all my work here. So here we go. So I'm going to do 2.5y plus y equals 140. All right, so let's see. I have like terms, so I'm going to go ahead and combine my 2.5y's with my 1y, which is going to give me 3.5y's equals 140. And then, of course, I'm going to divide by the 3.5 to get that multiplier off of my y. And that is going to give me, I already know what that's going to be, but I'm still typing it in, 40. All right, so it looks like I just figured out that there's 40 pairs of running shoes because running shoes is the y. Now I need to go find x. Well, I know x is 2.5 times y, right? So if y is 40, I can literally just type it in to that bottom equation, right? Multiply by 40, and I get 100. And of course, my answer is correct because 100 is 2.5 times bigger than 40. And if I add those up, I do get 140 total pairs of shoes, right? And so my answer is completely reasonable. So I'm going to write my sentence, right? I'm going to say there are 100 pairs of walking shoes. And 40 pairs of running shoes. Voila. All right, moving along. Here we go. The perimeter of a concession stand, now we will, it doesn't say this, but we are assuming the concession stand is a rectangle. All right, just so you know. The perimeter of a concession stand, rectangular concession stand, at the ballpark is 88 meters. The length is 4 meters longer than the width. What is the length and the width? All right, we've done quite a few of these in class. All right, so again, step number 1. Right. Again, I hope you're getting to the point of complete boredom at this point, right? Like, oh my gosh, we've done so many of these word problems, right? That they're all just kind of just starting to repeat, right? Just with different numbers. That's kind of where I want you to be at this point. So it says, what is the length and width? Okay, well, those are my variables. So I'm just going to make x the length and y the width, or vice versa. I don't care which variable you have as which, as long as at the end you attach them to the correct variable. All right, so here we go. We're going to go back to that very first question that said the perimeter is 88. Well, remember, we've talked about this in class quite a bit. I'm going to talk about it again really fast. If x's are the lengths and widths are my y's, then I know that perimeter is, remember, perimeter is adding up all the sides. So x plus y plus x plus y if I add all the way around. But that gives me 2x plus 2y, right? That is our perimeter formula. So when it says the perimeter is 88, then that means you are setting that expression equal to 88. I'm going to reset. So that is on you, right? You have to know the perimeter formula of a rectangle is 2x's plus 2y's, right? And I'm going to set that equal to 88. All right, then I'm going to go to my second sentence that says the length is, this is a write it as you read it problem. The length is 4 meters longer than the width. Okay, length is, well, my length is x. So x equals 4 longer than the width. So width plus 4. So there's our equation. X equals y plus 4. And oh my goodness, why are all of these set up for substitution? I'm really hoping our last two are not like that. I don't think they are. All right, so yes, I'm going to do substitution yet again because they give me an x equals equation, which means I can take that expression and go plug it in for the x in the other equation. So I'm going to completely rewrite that top equation but instead of x, I'm going to plug in y plus 4 and then bring everything else down. Plus 2y equals 88. And now we have an equation of all y's, so now we solve. So I'm going to distribute the 2, right? That gives us 2y plus 8. Bring everything else down. Now we add like terms. 2y's and 2y's give me 4y's. Bring everything else down. Now we have a basic two-step equation, so now we need to start moving everything to the other side to solve for y. So we're going to subtract our 8. So 4y equals 80. Divide off the 4 multiplier, and we should be getting y equals 20. And of course, I'm going to go back and solve for y by using my x equals equation. So x equals y plus 4. So x has to equal 24. And of course, before I go, write my final sentence here, I'm going to double check my answer. So yes, it does look like the length is 4 more than the width, 24. And if I add them up, 20 plus 24 is 44, but there's 2 lengths and 2 widths. So 44 times 2 does give me 88, right? So my perimeter would be 88. So yay. So then I'm just going to write my final answer. The length is 24 what? Meters. And the width is 20 meters. Make sure you put those meters in there, right? We want to have our units of measure so the person reading our answer knows exactly what our answer is in context of the problem. Okay, voila. All right, we got 2 more. Here we go. All right, number 16. I'm going to go ahead and write my x equals and y equals. There we go. All right. Let's see. A shipment of 3-pound boxes of cheese and 2-pound boxes of cheddar and Swiss, has a total weight of 510 pounds. There are 20 fewer boxes of Swiss cheese than there are of cheddar cheese. How many boxes of cheddar cheese are there? Okay, I thought we would get out of substitution, but it looks like not. All right, so how many boxes of cheddar cheese? Oh, so it's only asking for cheddar cheese, but that's okay. We still have to find Swiss cheese, right? So that's still going to be one of our variables, right? Typically, they would ask how many boxes of each type of cheese are there. Okay, so I'm going to go ahead and make X number of boxes of cheddar cheese. But Y is, I still have to find boxes of Swiss cheese, right? Because I've got to play those off of each other so I can actually set up the system. So even though it only asked me for cheddar, I still had to have a variable for both, okay? Sorry, to get that to go down. All right, let's go set up some equations. All right, so 3-pound boxes of cheddar cheese, so pounds, and 2-pound boxes of Swiss cheese, and a weight of 510 pounds. So notice everything is pounds, 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 pounds. It's kind of like money, 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 right? Everything involving pounds has to be in the same equation. So it's 3 pounds per box of cheddar plus 2 pounds per box of Swiss, and together that's 510 pounds. Okay. Then, again, this one's kind of tricky. There are 20 fewer boxes of Swiss cheese than cheddar. Okay, so you might need to think about this for a second. We talked about this in class. There are 20 fewer boxes of Swiss cheese than cheddar. Okay, so your options are either, I'm just going to put, so it's either going to be X equals Y minus 20, right? 20 fewer, or Y equals X minus 20. So you need to make sure that you pick the correct one, okay? Because you know it has to be one of these two. So just pay very close attention. It says there's 20 fewer boxes of Swiss cheese. So Swiss cheese is Y, right? So since we're talking about the Swiss cheese being the lesser number, then that has to be the variable that we're finding, right? If I took cheddar and took 20 away from that, then that would give me the Swiss, right? So that one is our winner, right? So Y equals X minus 20. It can't be the other one because the other one is saying in order to find cheddar, I would subtract 20 from the Swiss, right? And that's not saying the same thing. All right, I know those can be confusing. I always just kind of write it both ways and just kind of reason my way through it sometimes. All right, let's see. I thought we would be to a nice, pretty one, but it's still substitution. All right, again, if you want to convert to y equals mx plus b form and use the graphing method, or if you want to put this in standard form and go do elimination method, then that's totally fine. But it is set up technically for substitution, so that's the way I'm going to do it. All right, so I'm going to, let me scoot. I don't have a lot of room to work here, so let me scooch that over there. Okay, so I'm going to completely rewrite that top equation, 3x plus 2, but instead of times y, times x minus 20 equals 510. All right, I'm going to go through this pretty quickly, so I'm going to distribute, so 2x minus 40. I'm going to combine like terms, so I have 5 total x's. I'm going to add the 40 to the other side, which gives me 550. And then I'm going to divide by 5, which gives me 110. Again, I know I didn't show all my little interim steps there, but I figure we've done that enough times. We can probably get away from that a little. All right, and then of course I need to solve for y. I'm going to go back up to my y equals equation, right? So if y equals x minus 20, so that would be 110 minus 20, so y equals 90. And I can always check my answer as far as did I pick the right order for my system up there for that x minus 20, because right here I just solved for y, which was the Swiss cheese. Is my Swiss cheese 20 less than the cheddar? Yes, right? So that's another way I can check it at the very end. All right, so I only wanted the cheddar though, so cheddar was X, so I'm just gonna say there are 110 boxes of cheddar cheese. If you want to write the Swiss cheese one, that's fine, but it only asked me for cheddar, so I'm only going to answer the cheddar question. Oof. All right, last but not least, number 17. 2 customers purchased coffee and donuts. Each cup of coffee is the same amount and each donut costs the same. Okay, so let's see. The first customer paid $4.90 for a cup of coffee and 2 donuts. The second customer paid $8.60 for 2 cups of coffee and 3 donuts. What is the cost of each cup of coffee and donut? Okay, so at least we're getting away from substitution method, right? This is clearly going to be a standard form, right? Because we have item plus item equals total amount of money paid, right? So money plus money equals total money. So what is the cost for a cup of coffee? Okay, so again, I'm going to use my question to get my variables, right? So cost of a coffee and cost of a donut. All right, And in this case, each bullet is gonna give me a sentence, right? Because the first bullet is talking about the first customer. So the first customer paid 1 cup of coffee, so 1x plus 2 donuts, so 2y, and was $4.90. And please notice that is money plus money equals money because the variables themselves are money, right? X and Y stand for money, right? So we're still getting money across the board there. And then, let me go to a different, I'm gonna do blue. I'm gonna go to my second bullet point. So the second customer paid or got 2 cups of coffee, so 2x, and 3 donuts, so 3y, and they spent $8.60. So there's our system. Now this one is set up for elimination method because they're both in standard form, so that is what I'm going to use. Remember, you can cancel out whatever variable you want. I'm going to choose the x's because to me that would be easier since 1 and 2, or 2 is a multiple of 1. If you want to do the y's, you totally can, but you'll have to convert both equations so that you can get a positive and negative 6 out of those. But I know I can cancel out my x's if I multiply by negative 2 and turn that top equation into a negative 2x. But I do need to distribute it all the way across the board, right? So what's that going to give me? Negative $9.80 over there. And then let's see, I like to rewrite and keep my systems stacked above each other at all times so I don't get lost in my math problem, right? And so now I can add my system vertically because now my x's eliminate each other, right? And that's going to give me negative 1y equals, what's that going to give me? Negative $1.20. Is that right? All right. And then, of course, I'm not done because I have a negative multiplier on my y. So I need to divide by negative 1 to get that negative off. And which makes sense because my coffee's obviously, or my donuts aren't going to cost negative $1.20. Right, so that gives me 120 for y. All right, and then I need to plug that back in somewhere to solve for x. I'm going to pick the very top equation, or not, I'm sorry, not the top equation. I'm going to pick the bottom equation, the original guy, because I haven't messed up with him a lot. So it's going to give me 2x plus 3 times $1.20 equals $8.60. Sorry, I'm kind of cramming that in. So that gives me 2x plus 3.6 equals $8.60. Then I'm going to subtract the 3.6, which gives me 2x equals 5. And then if I divide by 2, right, I'm going to get x equals 250. And I know it is 2.5, yes, but I am talking about money. Remember, at the end of the day, we're talking about the cost of a donut and a cost of coffee, right? So now I'm going to write coffee is $2.50 and donuts are $1.20. Sorry, I'm kind of cramming that all in there. And voila. And of course, I can totally check my answer just really quick. I'm just going to go analyze each customer and make sure that gives me that correct amount. So I'm just going to use my calculator. I'm going to type in 250. That's 1 coffee plus 2 donuts at $1.20 a piece. And yeah, my calculator tells me that's $4.90. All right, and then I'm going to go check the other one just to be sure. So the other customer bought 2 coffees at $2.50 a piece plus 3 donuts at $1.20 a piece. And yes, my calculator tells me that that's $8.60, right? So yay, right? I know that that has to be correct. All right, that was a whole lot of work. I do want to talk about something really quick because I noticed it was not anywhere on this review. So if you can bear with me just for a few more minutes, I want to talk really quickly about the special cases. I'm not sure why they didn't appear anywhere on this review. I didn't write the review, so I'm going to just quickly review your special cases. So remember, there's two special cases. Special case number 1 is no solution. So let's talk about what that means, okay? So no solution, if you're doing the graphing method, if you're doing the graphing method, the no solution means parallel lines, right? Because the solution is the point they have in common, and parallel lines have no points in common, right? So they can't possibly have a solution, okay? But if you're doing like substitution or the elimination method, let's talk about what that looks like. So if you're doing, for example, let's say we do the substitution method, and I'm doing 2x, and I'm just going to do a very general case here, you guys. So let's say I get 2x plus 5y equals 8, and then I do some math, and I get negative 2x minus 5y equals 2. Well, when I add these vertically, right, my x's and y's all cancel, which leaves me with 0. But I'm left with 10 on the other side, and 0 is not equal to 10, right? That is a false statement. So when all your variables cancel, the x's and y's completely disappear, and you're left with a false statement like 0 equals 10, that's not true, then that is what no solution looks like when you're using the substitution or elimination method. Okay? All right, then quickly I want to talk about number 2, right? So the second type of special case is infinite solutions. Right? So infinite solutions means if I have a graph, if I use the graphing method, right, then that means I'm drawing, I graph one of my lines, but then when I go to graph the other line, it's on top of that one. So they're the same line, right? So if I happen to graph and I get the same line, then that is infinite solutions because they have all points in common. They're the exact same line. So all the points are in common, therefore infinite solutions. Okay? If you're doing substitution or elimination, what that's going to look like, I'm just going to kind of use the same similar example. Let's say I have 2x plus 5y equals 8 again, but then I have negative 2x minus 5y equals negative 8. So when I add these vertically, the x's and y's cancel, which automatically means special case, right? But then I have to ask myself, what am I left with even though the variables canceled? Well, notice on this side, I have 8 plus negative 8, which is also 0. Now that is a true statement, right? And if all your variables cancel and you're left with a true statement like 0 equals 0, or maybe it's 8 equals 8, or negative 5 equals negative 5, whatever you're left with, if it's true and all the variables are gone, that is an infinite solution scenario. Okay? All right, so I just wanted to review that really quick because it didn't pop up anywhere on the review, but I guarantee it'll be on your test somewhere. So just make sure you are familiar with those or you remember them from class. Okay? All right, you guys, I hope it helped us talking through, or me talking through those review problems. And I wish you lots of happy studying. All right, see you guys later.